Hello, good morning. It is Saturday, July, I think it's the 20th, around there. And today I'm going to be looking at this case here, the transformer on top. And it's my first product that I'm going to offer. And I'm going to also file a patent application for it. First, I want to mention I've been struggling with my health. It's delaying me a bit, affecting everything I do. And there's no cure or medicine for it, which is frustrating. And what it is, it's dangerously low blood pressure. I'll talk more about that later. Anyhow, here is, I had to mount the transformer on top of the case. There wasn't enough room inside after, I mounted the strip board up higher off the bottom using blocks and those standoffs. And when I turn on, this little light bulb will come on. It's a 6-volt bulb, but it's only got 5 volts applied to it. And that switch turns it on or off to test it. And you can also use it for a night light or something like that. Now this cord supplies 5 volt DC, and then I got to get another one to put in there. It's going to supply 12 volts DC, and I'll be done. And this transformer is a 10-to-1 step down. It outputs 15 volts AC out through the green wires. The black wires connect to 120 volts from the wall. So now I'll turn on and show you the current measurements to prove it saves some current. There's a little bulb on. Now I'll test the current going into the transformer from the wall. And it says 0.04 or 5. It's hard to see here because of the light. Yeah, before I measured 0.055. And now coming out of the green wires, or actually adding to the green wires, there's going to be some more from the capacitors inside. It measures 0.15, 0.15. But before, when I measured it, it went up to 0.18. So I don't know, it's varying a little bit. Maybe we'll try this other wire here. Oh, we're at the 0.21. Oh, why is that happening? Well, I guess what you can do is take the average of the two. So we'll say about 0.18. So I wrote it down here in the red there. 0.55 going in, 0.18 going out. In using the proportion formula, I think that comes to 68%, I can't remember, 68% or something like that. 68.5% or something like that. Now, But some of that is coming from the step-down transformer, and a little bit is coming from the capacitors discharging in the circuit. And the larger the load device attached to it, the wattage, will cause more current going through the whole circuit, and it'll save even more. Because when I had these bulbs here, I had 2 of them hooked up to the AC voltage divider. It saved up to 86%. I proved that in another video. Okay, so now what I'm going to do is take this case off and just show what's inside. I think I'll turn it off though, because it'll be safer. And I'll have to put this down for a couple seconds. Here we are. Okay, here's the circuit inside. It's all complete except for that one cable, 12 volt DC one. And I just have to glue those wood blocks to the bottom so it stays there. Now the module on the right supplies 5 volts DC through those black wires, and the one on the left will supply 12 volts DC when I connect the other cord to it. And those capacitors and the 2 diodes create the AC voltage divider. And those 2 big capacitors, they charge and discharge back and forth, going back into the secondary coil of the transformer. And what I've got the 12 volt DC module connected in parallel to it. So the current from the capacitors, some of it goes into that, and it saves more electricity. And it's like running 2 devices instead of 1 if they're both going. So it's really good. So I got the idea of using this by themselves, like 2 capacitors. Those are 100 microfarads, so they don't charge up much. But I had some 500 microfarad capacitors, but they're only good for 100 volts, so I couldn't test them out. But I tested them out using 60 volts AC from this transformer, step down, and I proved it saves current. So I ordered some newer ones at 680 microfarads, will save even more current. And when I get them, they'll be here about Tuesday, and I'll be able to prove that those work at 120 volts, because they'll supply more current to the load device, and there'll be more current coming off the capacitors when they discharge, and they'll go towards the opposite capacitor because the plate there will be attracted by the electrons, and it's going to go back and forth, and actually it's like taking some electricity from the past and use it during the present, but at the frequency of 60 cycles, 60 hertz, but it's like using the current from the last half cycle during the present cycle of each alternation. So it's going to be really amazing. And you won't need these big transformers, which will cost more money. And compared to capacitors, and there's no need to go above 120 volts. It's going to be spectacular if I get this working. But we're going to use both in the future and sell them because there only be so many chemicals available to manufacture all the capacitors, and only so many chemicals to make transformers, etc. So there you are. And I'll be making some other videos about this, what I got here, and also about something about my other project where I had those little, 8 of those little step down transformers. Something about that. And something else I can't remember, but okay, I guess that's all I want to talk about today. Thank you very much for watching.